Hello, everybody. Thank you for coming tonight. We're going to start in a few minutes, but in the meantime, here's the schedule that we have. Just some few logistic notes that the washroom is down there to the left. So go through the brown door there. Make sure the door is not locked. It shouldn't be. And then, come back in. The passcode is on the door itself. There's tea and coffee around. Welcome to help yourself. And we'll get started shortly. So I will make a 30-minute talk about data validation. And then after that, we actually encourage anybody who have data validation experience, also going to have been doing that either in the research or in the work, to come and share with us your experience. And also, anybody that's hiring for data talents, you're welcome to let me know, and we're happy to let you come up and do a few minutes of talk about what you're looking for. And after that, at 7:30, we will go to Butcher and Bullock, just a few blocks away, so not too far a walk in this cold weather. And we'll socialize, grab some food, and have some drinks. Thanks, everybody. Done. Okay, let's get started. Hello, everybody. My name is Boris. So I'm one of the organizers for PyData Meetup, as well as working here in Mobify as a lead data engineer. So I do quite a bit of data validation, as well as building up the data pipeline here. Just wondering, who else do data engineering and do data validation? Wow, that's quite a lot of people. Welcome, everybody. And just keep your hands up for a second. Who here like doing data validation? Give me a thumbs up. Two thumbs up out of this. So, okay. In fact, it's very interesting. I talked to a few people before we do this meetup, and part of the feedback is like data validation is like Marmite. You either love it or you hate it. And for me, like data validation always invokes certain feeling that think about you've spent days, weeks, or months to build up this data transformation, data pipeline that you have. Now, you got this baby that you spend a lot of time with, and then you start turning it on, and you start seeing real data come through. Very exciting. You wait a bit, collect enough data, and now is the time to do data validation. For me, it always feels like tidying up a messy bedroom, that you have been spending time doing something fun, and you realize that you make a bit of a mess, and now you're here to clean up the mess. And along in this mess, you will discover things that, hey, I never bought this piece of junk before. How did that happen? Which bucket should I put it? Or, oh my God, that's a giant rat that's living in a corner of my room. So this is kind of an analogy that I kind of like feel with data validation. And during this meetup, I kind of talked to a few people and trying to get a feeling of what they think about data validation. So some of the feedback that I got is that data validation is boring. So one quote actually I got, this talk, actually, I was talking to some of my friends and invite them to talk about data validation. One of the feedback I got is that actually data validation is pretty boring, but I can talk about something else on top of data validation so that to make it more interesting. So that's the feedback that I got. So today, everybody here is going to get bored for 30 minutes, and then we are going to drink our sorrow down. Data validation is kind of demoralizing. So what happens is that when you do data validation, you always find problem. And you find problem, you spend time to fixing it. It certainly slows down your development a lot. And it's something that generally team will underestimate the time that they require to do validation. And it becomes quite a demoralizing experience that you find one problem after the other problem. And it's a thankless task because a lot of time when you do data validation, you're poking hole. Either code that your teammates have written or code that is caused by data upstream. And that become a thankless task because you're just submitting this bug report, poking holes in other people's work. But ultimately, data validation is very important. It goes beyond how your organization treat data, but more importantly, I'm going to talk a bit more about later on how it can have a social impact. So first of all, let's clarify our definition of data validation. A lot of people think about data validation as something that you, for example, if you've got an input field that says email, validate that what comes in is indeed an email. If you have an integer field, validate is integer, validate that no data is missing. That's certainly true as part of the data validation. But I kind of want to take a step back and look at a bit more of what the big picture is. So a lot of time, we spend a lot of effort in building all these data pipeline, where you do a lot of complicated data transformation, or use a lot of interesting distributed technology. And when these pieces of work that you have done interact together, it's like a black box that even you spend so much time in building it, you know, written every single line of code, you can't guarantee the behavior is what you have expected. In fact, this is an exact slide that we use in our all hands show and tell to tell people about what engagement team does. And literally, we treat it as a black box, both to our organization as well as to ourselves. One of the phrases that we like to use is that we use data to guide us how to build data pipeline. All these configuration with the complex technology that you use, you can't guarantee that you get it right the first time. So we kind of need to instrument our pipeline in order to understand what it does and really treat it as a black box and only look at data to tell us what its behavior is. So our definition of data validation is actually whether the information that comes out of this black box is useful, is of quality, and is timely. And really trying to dive in and understand the behavior of the black box that you have created. In terms of quality, there's also a few definitions of quality. So for example, validity, which goes back into what I talked about, for example, whether it's of right type, completeness, whether all the fields that you expect exist, consistency, whether the data that you pulled out at different time is the same, or whether the same data that live in different part of your system is the same, and accuracy, whether the data is telling the truth. So with this definition here, let's take a look at a really complicated, concrete example. We're going to start counting words. So let's take a look at a data pipeline where we will count words. So for example, input stream, that goes hello world, hello friends. You count the number of words in the stream. 2 hello, one word world, 1 friends. Simple, right? We can do this. We can build this data pipeline. Okay. So let's write a simple piece of Python code that take in the stream, loop over it, and then whenever you have a word that you think is completed, put it in a counter. And in that also like filter out like, oh, if that word is empty, for example, at the start of the stream, then you filter out. So it's probably not the best way to do it, but it illustrates the concept of what we do with a data pipeline. We take a string of data, write some small iteration, and then produce an output. So this sounds quite simple, but now let's look at some edge cases here. So for example, what happens if the data come in that is like hello world, hello friends, but with emoji? So the first emoji is a globe, and the second emoji is a pizza. So what's the definition of word at that point? Does word include this emoji? Does the globe emoji associate the world? Does all my friends associate with pizza? So this kind of become a change of the definition. You really need to clarify your definition of the term word once you start building this data pipeline. What happens if you do a different language? For example, Arabic, where we go from right to left. Or whether it's Chinese, where the definition of the word doesn't actually have space in between. So when you build up your data pipeline, you always get this kind of edge case that come up, and you need to go back and modify your data pipeline to handle these edge case. And that simple loop that we have hacked up there quickly become complicated. So this is already sounding very boring and very thankless. But this is something that we can actually learn from another computing discipline that have done the same fight. Can anybody guess what that discipline is? It's a lot of fights like this that have been done by QA and testing already previously. So a lot of people think also QA is a thankless task. But they've done it so many years that they now actually able to make it interesting. So let's look at the history of testing itself. In 1950s, it actually started with more of a debugging style testing, where like nowadays, we don't even call it testing. It's basically just diving in when you see issues, diving in and finding out what's happening. And it started progressing over these 50, 60 years until now that we've got something called prevention-oriented testing. I'm going to talk a bit more about this later on. So here's actually an example blog article from a testing blog website that I have. This kind of illustrates the thanklessness that they think QA is. So this is very similar to what we do with data validation, the sense that, oh, like you discover a hugely complicated data bug that goes back 5 layers deep in your pipeline. Will anybody like slow clap and go, bravo? No. You're going to get into a lot of work in trying to fixing that. And in fact, testing got so interesting now that it actually become a competitive sport. So this is like apparently the Software Testing World Cup 2016 championship, taking the victory photo. So we managed to turn something like testing and QA into something that is quite boring and into something that's quite interesting. So how do we do that? So part of the big change in testing is something that is encapsulated in something called test-driven development. So test-driven development is a software discipline that allows, basically encourages you to write your test before you write your code. It's something that now has become so common. As a software engineer, I pride myself in talking about, hey, I write tests, I do good tests. So it's something that is something that is very common. Everybody talk about it, and people take pride in owning it. Not just the QA themselves, but actually software engineering does it as well. So it's become something that everybody does. And that's something that certainly we can take a lot of learning from. So there are things from testing that we can learn and apply to data validation, but as well as something that's very different that we kind of need to find our own way. So first of all, test is brought in the process early. What we mean by that is that actually, before you start doing any engineering, you start thinking about test. It becomes part of the design, it involves people early, and it becomes something that's accepted. You put it in your scope so that testing doesn't become part of the extra criteria. After you ship that things break, you come back and find out what the bug is. Testing is basically designed to code. So when you do test-driven development, one of the major change is that you actually think about how you can test your code. And in order to test your code, you've got to break your code down into small pieces where you can interact with it individually so that you can write unit tests and feed it certain input, expect certain output. That's something that we can learn with our data engineering pipeline as well. So for example, the loop that we just presented before, we can actually make it so that it can be easily testable. It's something that applies to a lot of data transformation because a lot of time I'll write a lot of research notebook where I find it will be a whole sequence of logic that's embedded in this untestable mess. I find it really helpful for me to structure my data transformation in separate steps that's testable. Also, on top of this, actually, by writing tests like this in small chunks, it actually helps you to explain the behavior of your code. So this is going to become really important later on. Testing is automated. So instead of getting someone to do manually testing, we try to encourage people to do automated testing. So once the software engineer writes this test, you're able to repeatedly run it every time you make changes, and therefore ensure that your software doesn't regress. This is something that we can do as well with data validation, is that if you change your data pipeline, you have to revalidate it. If you revalidate it, you don't want to do all the validation that you have done manually previously again. So it's something that we can learn. And testing includes everybody. It's not just become the QA department that's responsible for, but everybody that involved in code should be involved in the testing itself. However, that's something that's also very different. So this is a comic that one of our ex-colleague, Megan, she had on her table, kind of demonstrate how data is unpredictable. And in fact, data is unpredictable. Input data has huge variability when you deal with a real data pipeline. The fact is you can't think of every single edge case that you're going to face. You're always going to have data that's for your curveball that breaks your pipeline. Distributed system have variability. By definition itself, it's distributed system. That's something that called a cap theorem that determines that consistency is actually a trade-off between different properties of your system. So a lot of time dealing with data, you can't guarantee 100% consistency. Data definition in itself can also change. So similar to software requirement change. Data definition itself, for example, if you deal with a new piece of data, you've got to come up with a new way to explain this data and change the definition. So these kind of changes makes it slightly different approach that you have to take, that you can't write all your tests in front and then do your unit tests. We have to do something that adapt to it and do a lot more things in production. So we're going to talk a bit more about it later with some of the experience that we learned at Mobify. Actually, any questions so far? Okay, cool. So in Mobify, we kind of have a few fights with data. We win some, we definitely lost quite a few. But on the other hand, from this, we actually learned a few experience from this. So here's the team that I work with. That's Ashley, she's a technical product manager. This Ben, he's not actually on our team, but I'm going to include him in my team. Anyway, so he helps us, he's like really experienced developer. He do a lot of testing upfront, and I learned a lot from him. Carl, he has a background in everything that I know. So as you can see, that's not a real photo of him. That's actually a self-portrait of him. And in fact, if you look around the corner, there's an oil painting of our previous mascot of our team that you can see that is painted by him. And that's myself. And in fact, there's a lot of other people in our organization that helps out with doing data validation. So for example, the data insights team, customer success help out, product manager help out. In fact, since yesterday, QA was diving in and doing data validation as well. And yes, we are actually hiring. We have got 2 more headcounts with various data-related departments in Mobify. So if you're interested in hiring, definitely interested in applying, definitely talk to us. So let's go back into our example about word counting and see how we can apply some of these principles. So I actually have a GitHub repo that kind of demonstrates some of the concept. It's not quite a framework, but it's more like an example on some of the principles that we apply here. So I learned a lot from the team that we work with. So I'm going to go through the individual learnings that I have from the team members. So Ben, he does a lot of modular testing, and he's really good at testing of real data. So when I see Ben work, part of the work process that he does is spend before he even does any software engineering, he collect real testing data before doing anything. So for example, last Friday, he would spend a full half a day to work just to collect the fixture data, asking people about, hey, how can I get access to this data? How can I do this so that I can get a better set of data? And then go and tidy it up so that it become a good set of test fixture. He's also very good because he's test-driven, so he becomes really good at breaking down the pipeline design. So for example here, on the code on the left here, it's the same kind of code, same kind of word counting program that we have. But we kind of break down the logic of that loop into separate parts. So this kind of a map-reduce inspired kind of example. The first step that you have a process that consumes this stream of words. And you'll be a parser that basically tokenize each of these words and then output it in the stream. So you've got individual words. And then after that, you have got a function that actually simply filters out the empty words. And then after that, you've got the stream of words. You can have a counter that eat up all these words and aggregate the count. So you basically separate all these logic into individual pieces. And now you can apply tests to it, whether it's using real data, or sometimes after we see actually things that is meaningful in the real data that we have, we'll break it down and take it out and apply separate unit tests to it. So take the example at the bottom here. We've got a few assert tests. We test of the edge case how we should handle hello world with an emoji. So we break it down so that we take out the emoji. That's our definition of word. The definition of a word itself is actually captured in this test to explain. How do we explain how we interpret Chinese words in this case? So again, the test itself is a definition, and it explains the behavior of this black box that we create. The next big lesson that we learn is actually from Carl. We've got a lot of operation monitoring on our pipeline. So a particular part that we want to focus on is basically for each step of the pipeline, we will have errors reporting. And all these errors will bubble up into our error reporting system. And from there on top of that, actually, at least part of our pipeline, every single time these errors happen, we'll actually record not just what happened with the error, but we record the input data from the step that actually causes error. So therefore, when we discover these errors, sometimes it's a lot, so we don't actually go back and fix it immediately. We'll prioritize them. But afterwards, we immediately actually get the real data that broke up our pipeline, that we can actually immediately take out this data and rewrite the test to cover it. And this is something that helps us so much. Instead of like having an error that you discover and you got to go through manual debugging in order to capture the data, you actually already have this input data that's logged in a really accessible format that you can transform it into your test. So on the right here, actually, here's an example of how we envisage each of these steps should be. So again, we've got the emit words, we've got filter empty words, and we've got the count words. But for each of these steps, we actually wrapped around certain monitor around it. These monitors might not be actually a zero to run error in the pipeline, but it might be something. For example, we've got a limit on our maximum word length, that if that word is longer than a certain length, then we'll bubble this up as an error, but let it go for now. Let it go through the next step of pipeline. So when we come back, we'll be able to identify, for example, in the case of the edge case about Chinese, where the tokenizer that you work right on the first time, it might not work, and you've got this huge stream of data that you'll be able to at least sense something is wrong, and then be able to break it up, and you'll be able to identify that. Louis. That's a very interesting idea, but totally not. In a way, actually, we use something called Sentry for our error monitoring. So they actually do some really simple clustering the error based on the type of error that they see. So in a really naive way, we do actually have some like denoising of the data, but we haven't do any investigation into the clustering to identify where is the high-risk part of our pipeline. Any other questions so far? Okay, cool. And in fact, actually by having this monitoring wrap around each steps of a pipeline, it helps us with two really important principles of data pipeline writing. So it helps us to limit the scope of this exception. So one of the things that you do with data pipeline, data engineering, slightly different from normal programming, is that you want to be defensive on your programming. So what you mean by that is that when there's an exception happen, you want to handle it in as small a scope as possible so that it doesn't affect the other data processing that you have. You don't want the whole batch of the data to fail. You just want to keep that one row of data that you have that have issue away from making noise on your real data. And that is something that by having this framework, allows you to capture this and basically identify the exact input that causes this problem and isolate that input instead of having this fail the whole batch. Imagine that the first loop that we have, if it just throws an exception, is something that the whole batch will fail. And there's something that we want to avoid in doing data pipeline. For example, on a team, if we've got any function that do apply over a data frame column, we normally document it and make sure that any exception from that function should be handled within the function. It also allows us to gracefully retry and test. In certain cases, it allows us to gracefully retry and test whenever an error occurs within a data pipeline. So a lot of time, there's something called the exactly one semantic that a lot of time it's easy to do at most once. So what it means by that, if you fail, then you don't get any data, 0. But if you succeed, you get 1, you get some data. There's also one that if you fail, you retry, so that if you succeed, you get at least 1. But if you retry, you might get more than one set of this data. So it becomes a data duplication problem. Part of this is that by a framework that we use on Luigi, that by isolating these individual steps, we'll be able to have this exact one. So what happens is that when the error fails, it breaks on the unit that we fail on. And then after that, we actually goes in maybe many days afterwards to fix this issue, and then redeploy the fix that we have. Then it automatically rerun those failures and basically rewrite those unit of information. It certainly can apply in every situation, but so far in the case that we have, it actually works out really well. It also helps us to measure the inconsistency on each part of the pipeline. So sometimes you get data that's dropped on the pipeline, or you get, because of eventual consistency, that weird things happen. So this allows us to define certain monitoring on each steps of the pipeline. So instead of seeing that final outcome that's weird, we might be able to catch some of these inconsistencies within each step of this pipeline. Any questions so far on this? Yep. Yep, totally. So the question is kind of how generically applicable this kind of infrastructure is at. That's actually kind of why I want to present today, to see if there's any edge case that we can, it'll break it. So I'm certainly looking for feedback. So in terms of the experience within Mobify, with the application we have, we use a framework called Luigi, where it actually breaks down these individual steps will correlate to a task. And each of these monitoring will be in each of these task level. So for us, it's actually applicable for a lot of the data transformation work that we do. And it's an open source framework, so you can open to try out, get Luigi in, and try out for yourself and see if it fits your case. Is there any particular case that you think might be difficult to apply? Yeah. Mm-hmm. Yep. Mm-hmm. Yep. Yep, totally. So I totally agree that the validation rule can quickly get out of hand. So for example, here, you get down here, you get a simple function like check word length. You start doing frequency validator, you actually have to bring in some more complicated validation. So I'm certain that there will be cases that you can't validate at individual level, but you also got to look at look at validation of the different parts of the pipeline as a whole. But so far, for the basic monitoring that we have, this is very helpful for us to catch some of the edge case. Any other questions? Hi.
Are your data streams so large that when you detect errors, you attempted to set them aside rather than rerunning the whole stream after making a fix?
So, as in whether when we fix the error, whether we only retry on the error itself, or whether we actually rerun the whole set of data, a day of worth of data maybe. So right now, we actually only retrying on the units of data that is broken on. So this definition of this resolution unit is still as small as we hope. So it's not on a per row level, but it's not a whole set of data that we have. So rerunning this is certainly really positive. It's something that we are doing, and it's possible. Okay. So the next learning that I have from our team is from Ashley. So validation should be something that's done by everyone in the organization. In fact, in Mobify, we encourage something called data democracy, where we encourage anybody in the company to look at the data that we have and kind of trying to find something interesting, or if they've got anything wrong, go into this platform that we have and trying to do a bit of debugging, maybe with our help, and understand what's going wrong. So on the left here, there's actually one of our platforms that's called that's running on an iPython notebook or Jupyter notebook, where with the right credentials, you can go and access it and basically dive into the data that we have. And it allows people to actually dive in and understand what the black box of this behavior is. Because on this platform also, actually part of the data transformation code that we use on our pipeline is also available. So in theory, you can actually rerun, not as the same scale, but you can rerun some part of the code. For example, the enrichment function that we have over the input data that you think is going wrong. Actually, like last week, actually, she was onboarded onto this platform, and she's able to dive in and understand some of the working on the pipeline and find out one of the issues that we have with our data pipeline. And having this platform actually make it really easy because a lot of difficulty with handling data, for example, such as handling credentials on which database you talk to. You talk to 10 databases, like you get separate credentials for all of them, and it leaks everywhere within the organization, or you have to create different users for every one of them. It also allows her to basically, by just sharing a link, she can share the work that she's doing. If she writing a notebook investigation, she run into the problem, she can just send me a link and ask what's going wrong here. Am I doing something wrong? And we'll be able to provide technical help, as well as she can share the work that she has done really easily. And on top of that, this is actually the greatest data bug report tool there is ever, because everything she runs is reproducible. So once she found a bug, she can actually just submit the link of this notebook, and immediately we can reproduce this bug immediately in this notebook. So she actually, this is the dream of QA, where someone have written a bug report that reproduces everything for you. So for us, it's super helpful if there's a data platform. So it's kind of a summary of the lesson we learned at Mobify, that we try to do our data validation early and baked into code design. Be open to each other so that we can explore potential problem with the data. So when someone come to us and go, oh, that's an issue with our data, we can't try to prioritize, but also encourage them to dive into the notebook themselves and try to find out what's wrong with the data. And also, we try to test real data. As we mentioned, we spend a huge amount of effort in making sure that we use real data instead of factory generated data. So a lot of time with tests, you've got two different approaches with grabbing test data. Either using factory generated data, where you describe certain property of the data and then generate a huge variation of it. Or you can grab a test data that you actually, from real pipeline, that actually explain, may not have as much variability. So every time you run tests, it might be the same data that you have. But on the other hand, it ensures that you're focusing on the problem that happened on a real life instead of something that you generated, which might not affect you, might not happen in real life. Any questions? And any suggestion? More importantly, anybody have suggestion on ideas on how you do data validation that is totally different and brick? Yeah.
I have a question actually. So I've not used Jupyter notebook myself a lot. So this is probably a very basic question, but how is all the data stored in CSV files, or do you have a connection to various databases and you write queries on top of it to pull in the data?
Yeah.
How does it actually work?
Yeah, that's a great question. Anybody here familiar with Jupyter Notebook or not? Okay, only a few people. Okay, so Jupyter Notebook is basically cloud-hosted platform. So in fact, the data storage itself does not actually happen in a notebook. So as in, it doesn't have an actual copy of our database with it on the notebook platform itself. It have the like you mentioned, that it actually have connection to different database. The credentials is hidden behind the platform itself, so that it's even use a platform, you don't necessarily need to know the credentials. You can, however, generate local cache of the data. So you can definitely write the data to, for example, your local CSV file or HA5 cache. So whatever format that you want. And so that helps, for example, if it takes 2 days to put down your data, then you can actually write a local cache so that next time you rerun it, you can actually have an easier time. Yeah.
The clusters, you had there something called clusters in Jupyter Notebooks. Does it have some connections to the Jupyter HDFS? Is that how you run clusters in Jupyter?
So the question is, what's the distributed capacity of Jupyter Notebook? I haven't actually used that feature. Anybody have used that feature here? But Yeah, thank you. And there's certainly, I know that Jupiter is actually actively working on that. So locally in Vancouver, luckily enough, there's a company called Continuum. And Continuum actually responsible for a lot of these cool features. And part of the focus they have is trying to scale out this Python data set, where like previously it's really good at scaling up, but now they're actually doing a lot of effort in trying to scale out so that, oh, you can run a cluster, you can distribute your computing, you can talk to Hadoop if you want. So I know that there's certainly a lot of rich feature in it, but we are not tapping into that yet. Hey, Ganesh? Yes. Yeah, it's exactly the same thing. Yep.
You can like share it with people and stuff like that.
Yeah, exactly. So that's one of the great way to share as well. Like put it into GitHub or Gist and share it with people. That's something that I find really amazing as well. Hi.
You mentioned Luigi as a pipeline.
Mm. Do we use other? So we've got quite a few different data technology that we use on our data pipeline. Luigi is certainly the one that come into like handling the error and the processing on the exactly one semantic. That's certainly the most important technology that we have. We also use a lot of different technology, Kafka, Flink, Cassandra, but on the other hand, it's part of the pipeline, but it doesn't do as much of that transformation work as Luigi does. Yeah. Sorry? No, we haven't actually. So that's something. Okay. Are you guys using it at the moment? Okay. Do you have any infrastructure for that at the moment? Okay, cool. No, definitely come talk. I would love to learn a lot about different options as well. So it's one of those things that if it's not broken, don't fix it. And so far, Luigi have been working out for us. We do use PyTest for our testing, but no, I haven't actually.
It basically creates a set of tests that test the edge cases. It creates edge cases, it discovers edge cases, it actually builds new tests
Uh-huh.
to further test out.
Yeah.
It's actually a really good module to fit into this.
Sweet. So it actually fuss through the different potential data input and cool. Yeah, definitely. The module is called Hypothesis for anybody that want to check it out. Thanks. Ganesh? The main flow that we have now is from S3 into Redshift. So Redshift is basically the data warehouse that we use. That's kind of the main source and main destination. We've got other like small pieces of information that we pull from different systems that we aggregate and enrich, but those are not the majority of it. Yeah. Mhm. Mhm. Yeah, totally. Yep. So we actually run into cases like that before, and it's certainly something that we like. To be honest, I don't have a good answer for that. In a way that if you don't know what is your 0.1% is important. It's really hard to monitor and validate for it. But on the other hand, if we do, then there's something, for example, if there's certain browser that come out that you think is important, that you can include that in the monitoring steps that you have in this example. So this is something that we can do. We don't do it as much as we should. We have plans to say that we will do that, and that's something that we're certainly looking forward to. Yeah, and in fact, that's a really good example where minute change in your consistency of your pipeline can cause huge issue. And in fact, actually, one potential answers that might be interesting is that Kyle is working on something that's quite interesting. I'll let him talk a bit more about it later on in different presentations. But he's got a kind of a related background with telecom. So one of the ideas that he has is that he'll put through a signal on one side of the pipeline, and you expect that the full signal to come out on the other side of the pipeline. So in a sense that you can put, similar to how you test telephone line, where you can put through a test signal and say, hey, is my pipeline actually dropping 80% of the information? In that case, that will signify that maybe that 0.1% is actually in great danger of being impacted. So that's one potential that you can use to help to monitoring this kind of more complicated operations issues. Yeah. Mike. Anybody have comments on that? How do you do that at the moment, actually, Mike? How do you do that validation at the moment? Yeah. Yeah, actually, that's a great example because at Mobify, we are relatively lucky that we focus on one mainstream for events. I'm certain that's going to change, but that's certainly incur a huge amount of additional complexity in the data validation. Oh my. Yeah, thanks for raising that, Mike. Yeah. Do you want a minute to come up and talk about it, the challenges that you face? Or? Yeah. Okay. Yeah. Yeah. Feel free to come back, and we're always looking for presenters. So if you've got any interesting challenge, totally understand. And yeah, actually, that's an open invite to everybody here. I know a lot of us here have interesting topic that they work on that is shareable. So definitely, we are looking for speakers. And if you've got anything interesting that want to share with the community, always welcome to give us a shout on the meetup, and yeah, we can go from there. Finish. Yeah? Yeah, actually, come and take a mic.
Hey guys, my name is Ganesh. I presented at the meetup last year, so happy to be here again. So we built a SQL data analysis platform. And something we realized is a lot of people don't understand how powerful SQL can be. A lot of people have only used SQL through the ORM, which is very different from doing data analysis. So what we did is we wrote a set of 10 recipes that you can do with SQL. And we submitted this to Reddit, and it was on #1 spot for an entire day. Drove like 50,000 page views. In fact, in our analytics, you can't see, it looks like we haven't been active the past couple of years because the bump is so big. So I just want to share that with you guys. Can I connect to internet. How many of you are familiar with window functions in SQL? Sweet. So window functions lets you drag a slider along your data. So you can reference previous row, previous window. So you can do things like running totals, all the kind of stuff that's super simple to do in Excel. So it has dialects for Redshift and Postgres and SQL Server. MySQL, unfortunately, doesn't support window functions. So if that's your life, sorry. Sure. How do I zoom in? No, he wants to zoom in the URL. Why don't I open up text edit, and I need to pass.
What are you doing to my computer?
No, it's like, okay, why don't I just, yes. So siloda.com/docs. So really simple, business analysis, like what is your cumulative sum of customers who signed up, or reports they created, or how much revenue you've made so far, either this quarter or this month or this week or this hour if you're a big e-commerce company. Top N items per group. So I was cringing when Boris showed that Python code because the number of passes it does through the data is a little crazy. And so if you inspect the query plan that some of these advanced databases perform, like they generate for you, they're pretty sophisticated. Something else that came up was outliers. So Z-scores is a way to normalize your data sets. So if you have something that's, what would be a good example? Okay, I'm going to take my friends from GetStat here. Let's say they do SEO, search analytics. And so let's say you set an alert on a keyword that has 1 million searches per month. And then you have another keyword that has 100 searches per month. Now, if you set a rate-based or a rule-based tolerance on these limits, you have to fine-tune them for every single set of volumes, right? So the best way to do that is to normalize it using Z-scores, and now you know the deviation and how many standard deviations they're away from the mean, assuming your data is a normal distribution. So how do you compute Z-scores without multiple passes? Percentiles, if you have burstable billing, if you're dealing with response times, averages don't mean a lot. If you're looking for time on site, which is huge in engagement, again, averages don't mean much. So you're looking at 95th percentiles. And there's a whole list here. This is a commitment to the community that we have to write this stuff. I'm not even sure if a lot of this stuff is possible. So that's all I have to say. Thank you.
Actually, one quick question.
Yeah.
So a lot of time actually I run into the issue where you write a hugely complicated SQL function, maybe involving window functions. So how do you validate the result of that is correct normally?
So the question is, if you have a huge SQL statement, how do you validate the steps here? And generally, it's an organization thing. If you're using Redshift or Postgres, you can make use of CTEs, and you can execute these CTEs independently. And so you'd essentially write a test wrapper over the query, and then you assemble your complete analysis over these building blocks. So for example, if you have a unique definition for what a repeating user is, then you would create a CTE for just this, and then either create a view based on that, and then you would write a unit test on that view, and then you would structure your analysis, right? It's great for ad hoc queries where you're writing this complicated stuff, but if you have to maintain it, it just gets all over the place.
So how modularize your
Exactly. Yeah. any, yep. Awesome. So I'll repeat that. Microsoft apparently posted a blog post on how to use deep learning in SQL. Is it native SQL or they make API calls to their backend services? Because I've seen that a lot with Google. They say you can do everything in SQL. Well, really, you're making HTTP calls to an API service out there. Like, so, thanks.
Cool. Thank you, Ganesh. All right. Actually, just a quick last point to wrap up. So we talk about a lot of the technical point on data validation. I kind of like promise about like talking some of the social impact on data validation as well. So I just want to talk quickly about this. So we talk about validating black boxes. In fact, a lot of these black boxes happen in the society as well. So this is a book that recently came out called The Weapon of Mass Destruction. And it's actually a really good book. I definitely recommend you check it out. It's written by Kathy O'Neill, and she actually described quite a lot of big data algorithms out there that's actually doing decisions for you out of these data, but in a quite scary way. So actually, take one of the examples that she has talked about. So in chapter 5, she talked about civilian casualty. Do you know which film is this? Minority Report. And it's quite an old film, but on the other hand, the promises of this film, sorry about the spoiler, is that apparently that's a model that they have that can predict, well, the model, but predicts whether you are going to commit crime. And therefore, they arrest you before you commit a crime. And it happened that Tom Cruise is one of the policemen that did that, but the algorithm, well, the model that applied has gone wrong, and he become one of the victims, and thereon. So it's kind of quite interesting. But in fact, one part of the book mentioned is that this is actually a real-life scenario where there's actually a service called Predpol, where they will actually predict where is the crime, trying to increase policing efficiency and trying to predict where crime is most likely to happen, and therefore, like increasing the police allocation in that area. And this creates a huge problem because it started as a consultant company. They developed this proprietary algorithm. It's not something that's a black box. That's not validated. And also, one of the problems that she mentioned is that it's something that is self-confirming. So in a way that if you allocate more police into area that is potentially risky, such as, for example, a poor area or area that certain race have gathered, that this might actually you might catch more crime in that area, and therefore it's more likely that that area will be targeted in the next iteration. So it's kind of interesting. I mean, definitely go and read the book to see the details. She actually included a lot of the third-party reference in the book. The free signal that she mentioned is of the weapon of mass destruction. It's the scale whether you can collect huge amount of data and make a huge amount of decision. Intent, whether the algorithm decision that you have is going to change people's life. But the third part is actually opacity. So whether that model is acting as a black box. So a lot of time in future, she mentioned in the end, in the conclusion, that you definitely, a lot of time you need the society to come in and open up this black box. And this will certainly apply more in future on how we can validate these kind of big data algorithms to understand their behavior. So with that, thank you very much. That's the end. So actually, I promised kind of a data panel. I feels like it's probably, I've talked to a few people that they've actually have looking to hire. So is anybody here that want to come out and just talk about what they're hiring for? For sure, yeah. If you can come up here and just queue up, then. Cool. There you go, Anish from GetStats.
Okay. Thank you, guys. I'm Manish from StartStage Analytics. We are an SEO data analytics company. I think Ganesh was mentioning that already before. So we crawl Google, Yahoo, and Bing. We do it on a very big scale. We do it every day. So we have like a big distributed system to do this, and we have a lot of data pipelines. Some of them in Ruby Rescue, some of them in Spark EMR. So we are hiring data engineers. We are also hiring data analyst interns. If you guys are interested, come talk to us. There's a few of us up in front here as well, and myself, so you can come talk to any one of us. The other actually thing that I wanted to mention is we're running this distributed systems and data pipelines meetup. It's actually, I think it's advertised on PyData as well. So the next one is on February 23rd. In that one, I'm actually going to be speaking, and I'm going to be presenting on Elixir and the OTP framework. I've started playing around with it quite a lot recently. There's a few challenges that we face with using Ruby and Rescue as a distributed system, and I think the Erlang VM and how OTP is set up solves some of them. So I won't go into all of it right now, but if you're interested in knowing more about it, I'll sort of cover some of the advantages, disadvantages, and the lessons I learned during the talk. Thanks. February 23rd.
Hi there, my name's Stephen. I'm here from a company called Black Duck Software, and we're hiring for two positions. One is a data scientist position. It's an internship, which is starting immediately. The kind of data we are interested in is in open source software and behaviors and their vulnerabilities. So the kinds of data we're scanning is GitHub and SourceForge and all that sort of thing, as well as the vulnerabilities associated with it. We're also hiring a position called a program manager, and this is for somebody who's done some software development in their past and is interested in doing more managing of projects now. So we have a bunch of data scientists who are developing algorithms and processes for processing the data, and they need help moving to more of a kind of a agile development. We need Scrum Masters and agile development, so we can insert some of these processes and algorithms into the customer's product. So it's a new company. The company, the owning company, is an American company based in Boston. We've been here for just since April of last year, and we're about 13, 14 people in Burnaby. So if you're interested in working for a little company, which has a medium-sized company behind it, you can come and talk to me. I have descriptions of what the jobs are like, and I have questions and business cards if anyone wants to talk about it.
Oh, did I mention Mobify is also hiring? Yeah, if you're interested in any talk about what we do, please talk to us. John, our CTO, is here. Also Noah, back there. And also Kim back there. She's also working with us. So yeah, definitely come and talk to us. And any experience that you have data validation, please, I would love to hear your story as well. So thank you very much. Yeah, thank you, everybody. We're going to hang out here for a bit. I actually make a reservation in, what's the name of the club? Butcher and Bullock, that's the one. Butcher and Bullock. So it's down on Panda. So we're going to head out in probably like 10 minutes. So yeah, come along and join us for a show. Thank you.